So the topic to be covered today is what are the signs of a chemical reaction? If we're doing a lab where a chemical reaction is happening, how can we tell a chemical reaction is happening? And why are those signs of a chemical reaction happening? So a reminder, what is a chemical reaction? Go ahead and pause this video and tell the person next to you and write down what is a chemical reaction. So hopefully you pause this video, and you should say to the person next to you that a chemical reaction is when atoms are bonded together in new ways, or you can say that different compounds are formed than before. Because what's a compound again? Tell the person next to you, what's a compound? A compound is a combination of certain numbers of atoms, right? Or a combination of elements together, bonded. So if there's a chemical reaction, we have different combinations of atoms than we had before. Now, the definition I'm giving you here, a process that involves the rearrangement of the molecular or ionic structure of a substance. So we have a different molecule than before, which is again, what type of compound, what type of bonds does a molecule have? You should say, tell the person next to you, pause it, tell the person next to you. You should say, covalent. And then what type of bonds does an ionic compound have? A salt? What type of bonds does an ionic compound have? You should be able to tell the person next to you it's a ionic bond, right? Now tell the person next to you, as a reminder, describe the structure of a covalent bond and describe the structure of an ionic bond. Pause this video, tell the person next to you, and have the sub ask someone. Okay, hopefully you paused this video, you told the person next to you, and you had the sub ask someone. So you should say a molecule is covalent bonds where the electrons are shared, and to be fully accurate, the electrons are between the nuclei of the atoms, which is the most attraction, least repulsion. Ionic bonds, you should say that you have positive and negatively charged atoms in a grid. Okay, so what is a chemical change? What is a chemical change? Again, a chemical change is the rearranging of atoms into a different compound. So we have a different compound. That is a chemical reaction or chemical change. And what are the signs of a chemical reaction? In other words, how could you tell a chemical reaction occurred? That is the topic of this lesson. Now think about it like this. Let's say that you are a detective, okay? And if you're a detective, you're trying to figure out who murdered Sally. Okay, you want to find out who murdered Sally. And a witness says, I saw the murder. You might ask them, what did you see, right? They ask, what specifically did you see? You didn't see the words in midair say M-U-R-D-E-R, letters physically in midair, right? You saw something that implies that you think that this person murdered this person or whatever. And based on that evidence, then they can find how convincing it is. So maybe you just saw Mr. Kimmer carrying a knife. Oh, he was the murderer. Or maybe, you witnessed an attack, right? So those are different levels of evidence. And so you need to provide specifics. So in chemistry, you can't just say, I saw a chemical reaction. I tell students, no, you never see the words chemical reaction appear in the air. Okay? No, you see signs of a chemical reaction. Kind of like another example, like if two people are in love, right? They don't necessarily tell you they're in love. There's signs that you can see that they are in love, right? So similarly here, you need to provide the evidence. You can't say, oh, I saw the reaction. You're telling me what you think you saw. Tell me what you actually saw. You saw something change color, or you saw the temperature change, or whatever. Pardon me, I have a cold. I'm not used to this weather. So again, what did you actually see? What is the evidence? You didn't literally see the words reaction in the air. What did you see? And so we're going to talk about some of those signs and examples of a reaction. So here are signs of a chemical reaction you might see. Color change, fluorescence, change of temperature, gas production, and precipitate. These are signs of a chemical reaction because they indicate that different compounds have been formed than what we started with. So they're all signs that probably or maybe new chemical compounds have been formed than were there previously, which is evidence that a chemical reaction occurred. The first one is color change. The new compound, due to different physical structure, reflects light of different wavelengths, so the compound appears as a different color. So something, if you were to take physical science, talk about quite a bit, is your eyes see the color of objects is what wavelengths of light are coming to your eyes. Okay? So if an object appears red and orange, that object is absorbing blue, green, purple, so you don't see those wavelengths because the object is absorbing those colors, but then it doesn't absorb, it reflects the red and orange. So you see red and orange from the object. Whereas if the object is green, blue, then if it appears green and blue, then it is reflecting green and blue and it is absorbing the reds and oranges. So you see the light that is entering your eye from the object. And so, oh, it's hard to talk. Bad cold. And so, if there's different wavelengths of light being absorbed and reflected, that means that it's likely a different compound. And if it's likely a different compound, then likely a chemical reaction happened to make there be different compounds than there were before. The next example is fluorescence, the emission of light by a source that has absorbed electromagnetic radiation. So electromagnetic radiation is in light, so like sunlight or other sources of that type of energy. Electrons are excited and then drop back down to a lower energy level, releasing energy as light. So this is similar to when we did the lab where you had chemicals that you put under a fire. You're providing energy into them, and the electrons get excited, and then they drop back down at energy level, releasing energy, and some of that energy is released as light. Well, this can also be a sign of a chemical reaction, depending on what you expect to take place, where the electrons are excited. A change in temperature can also be a sign of a chemical reaction. So if it's exothermic, then the temperature of the surroundings will go up because the chemicals are releasing energy. And that's when the new bonds formed contain less total energy than the bonds broken, as we've learned in the previous lesson. Endothermic is when the new bonds formed contain more total energy than the bonds broken. And so then the new bonds have more energy than the bonds we started with, or taking in more energy. And so there's an increase in energy of the chemicals. Another way we said this previously, you can think about, remember that breaking bonds, does that take energy or release energy? Tell the person next to you. Does breaking bonds take energy or release energy? Breaking bonds takes energy, right? And then forming bonds does what? Tell the person next to you. Forming bonds releases energy. Okay? So if it's exothermic, then the released energy is greater. How can I put this? The formed bonds. So we have formed bonds releasing energy, and then the breaking bonds takes energy. And so if it's exothermic, the new formed bonds release more energy than the breaking bonds required. And if it's endothermic, it's the other way around, where the new formed bonds don't release as much energy as the old bonds broken required. Okay? So These are opposites, as we learned in the last lesson. But either way, an exo or endothermic process can be a sign of a chemical reaction. There's some kind of edge cases, like if you're dissolving something in something else, it's not technically a chemical reaction, but there can be an energy change. But this is a good sign of a chemical reaction, a temperature change, and this is the underlying logic of why. And so as we learned in the last lesson, there is endothermic and exothermic reactions. So in endothermic reactions, the products have more total energy than the reactants, and in exothermic reactions, they have less, and so energy is released. And then remember that hump in the middle is the activation energy, or the hill, the amount of energy needed to start a reaction, as we learned about before. And so it always takes a little bit of energy to start a reaction. And so similar to here, in this picture, we have a ram, and it's like that's like representing the energy to get the reaction going. Students often ask, where does the energy come from to get a reaction going? Well, sometimes it starts from an outside source. Like for example, if you burn alcohol, a little flat of like a spark or just a small flame will then start the reaction over all the alcohol. Or often a reaction can just start because the chemicals themselves have energy, because anything that has a temperature has energy. And the higher the temperature, the more energy those particles have. And so the easier, more likely it is that any single particle will have enough energy to overcome the activation energy and react. And sometimes, when certain particles have enough energy to overcome the activation energy and react, if it's exothermic, that releases energy, which makes all the other particles hotter, and so then it speeds up the reaction, makes it happen quickly, depending on what reaction's taking place. But there's always an activation energy, even if it's exothermic, because if you recall the transition energy, tell the person next to you what's the transition state. Okay, you should have paused. Tell the person next to you. The sub can call and someone ask, what did they say is the transition state? You should say it's when the bonds, the reactants bonds have broken, but the products bonds haven't fully formed. So it's the highest energy point, and that's why there's an activation energy again, right? And so it always takes some energy to get through that transition state, whether it's endothermic or exothermic. And that can come from an outside source, or it can come from just the energy and the temperature of the chemicals themselves. And so remember, breaking bonds always requires the input of energy, and a reaction releases energy if the products have a net lower energy than the reactants. It is like how lifting a ball or rock always requires the input of energy, but there is a net release of energy if the final position is lower than the initial position. It is also like this. Sam sells a bicycle. It is impossible for Sam to lose money selling a bicycle. So just like bonds formed always release energy, Sam selling his bicycle will always like cause a certain change in, or let's say if he's gaining money, it would be like gaining energy. So breaking bonds always requires energy, right? Breaking bonds always requires energy. Like Sam selling his bicycle means he's getting more money. Breaking bonds always means there's more energy entering. But if Sam then buys a motorcycle, it is possible Sam will have less money than he started with. There's a net loss of money. So similarly, if we start with a certain amount of energy, yes, the breaking bonds always requires energy. But then, if the forming of the new bonds has releases a lot of energy or is way lower energy than the original bonds, then there is a release or loss of energy, a net release of energy. Just like, yeah, Sam can sell his bicycle and get some money, but he can still net lose money if he then goes and buys something more expensive than what he started with. Okay? Kind of similar as a metaphor. So you could go out with the sub and take a ball and put it on the second story, and just like the hallway on the second story next to Mrs. Barker's class, and you have the ball on the floor. to get the ball to fall to the ground, the ball is higher energy on that second floor than it is on the first floor, right? It has more potential energy. But it's not easy necessarily to get the ball to fall without some activation energy. If you kick the ball and then the ball has a chance to roll down the stairs, right? Which is kind of representing like the energy that the ball would have, as it's like a molecule with a certain temperature has a certain amount of energy in it. And the higher the energy, the more likely that it will overcome the activation energy. So if you kick that ball as if it has a certain amount of energy in it, if you kick it hard enough, it's more likely that it will be able to reach where it needs to go to actually then fall down the stairs and release energy. See, there's a little bit of energy needed to get it going, but once it's going, it will go all the way to the product, which is reaching the first floor. So if someone has a ball in your class, you could pause this video, do that demonstration, and then answer the question in your notes on what does that mean. Okay, activation energy, why? To put in words my explanation that I was saying. The rate at which reactants form products and overcome the transition state may be increased by the insertion of energy from outside the system. So for example, heat, as I've said, like a fire or something, can be used to insert energy into the system in order to make the reaction happen. So heat can be inserted to provide the activation energy to make the reaction go quickly. And so MASH is an example of this, like when put fire on the alcohol that's on a paper bill, for example, you make the alcohol burn, you're providing activation energy with the match or the lighter at the beginning. Another example of a chemical change is gas production. The formation of a gas indicates a different compound is formed with a lower evaporation point. So like at room temperature and room pressure, certain chemicals are solid, certain chemicals are liquid, certain chemicals are gas. So if there's a chemical reaction, it's likely that you could see a gas when there was no gas before, because different compounds have formed that are gas at room temperature and pressure. So if the temperature and pressure of the environment hasn't changed, but then there's a gas there that wasn't there before, well, there's a good chance it's a different chemical than what you started with. So like, for example, you could have a certain chemical that's a solid at room temperature, or it's aqueous at room temperature, but then it forms CO2, which is a gas, or oxygen, which is a gas. And now suddenly you see a gas where there wasn't any. Well, that's because a new compound is formed, which indicates a chemical reaction. We also have precipitates. This is the formation of a precipitate, indicates a different compound with a higher melting point and or a lower dissolvability has formed. So this means that the chemical, the new chemical formed doesn't dissolve as well in water, so it becomes a solid. So different chemicals dissolve to different degrees in water, and or different chemicals are solids as opposed to liquids at different temperatures. So if the pressure and temperature of the environment hasn't changed, but now there's a solid where there wasn't a solid before, that likely indicates that there was a chemical reaction, where now, if it's in liquid, you formed a different chemical which doesn't dissolve as well in water, so now you see a solid, or you formed a different chemical that is a solid at a lower temperature than the previous chemicals you had, and now you see a solid where there wasn't before. So because, again, different chemicals dissolve to different degrees in water, and different chemicals are solids at different temperatures, then if the temperature and pressure hasn't changed, and there was no solid before, and now there's a solid again, that is indicating that you formed a chemical that doesn't dissolve as well in water, and so now it's a solid when there wasn't, or you formed a chemical, like if it's not in water and it's just sitting there by itself, well, it's a solid if now it has a higher temperature needed to turn it into a liquid or a gas than the chemicals that were previously there. So maybe you had a chemical that was, maybe you had some gaseous chemicals, for example, and then there's a solid there. Well, the new chemical that's a solid requires a higher temperature to become a gas than the chemicals that reacted. Okay? So that is how a precipitate is also a sign of a chemical reaction. So I think if you have time after answering the Boltzmann distribution questions and the previous questions, you should look at the outline. Excuse me, you should look at the outline and answer all the questions you can for this quiz, because I think the next class I'll give you a quiz on what are the signs of a chemical reaction.